Hey Alana, this is Miss Tracy. So I'm working these problems that you sent me in the order that you sent them to me. So we're starting with this lesson 112. So here we've got square root of x squared plus 11 minus 9 is equal to 0. We add 9 to both sides. We square both sides, which gives us x squared plus 11 is equal to 81. Subtracting 11 from both sides, we get x squared is equal to 70. Unsquare again, and then we get x is equal to plus or minus square root of 70. We've got two blanks for the value of x, so we have to split this. Positive square root of 70, negative square root of 70. All right, then we have this problem that says if one leg of a triangle is 5 inches and the hypotenuse is 9, what is the length of the second leg? So you just draw your triangle so you can visualize it. You got 5 for one leg, 9 for the other leg, and I just put b for the second leg. So we did Pythagoras theorem. 5 squared plus b squared equals 9 squared. So 25 plus b squared is 81. We subtract 25 from both sides. B squared is 56. Unsquare everything. 56 is factored as 2 times 4 times 7. So 4 is the only thing that we can pull out and make that a 2. So 2 times the square root of 2 times 7, which is 14, would be the length of B. All right, moving on. All right, the next problem says the brigantine was sailing at full speed and was 30 miles at sea when Lord Nelson began to give chase. So he's 30 miles ahead of Lord Nelson when the time starts. Then it says if Nelson caught up to him, when Lord Nelson began to chase at twice the speed of the brigantine. So his speed, Lord Nelson's speed, is 2 times the speed of the brigantine. So R, Lord Nelson, the rate of Lord Nelson equals 2 times RB. So we're going to use that as a substitution value. So then it says that if Nelson caught up in 6 hours, so the time was the same for both, because when he was 30 miles at sea, he began, and 6 hours later, he caught up with him. So the time is 6 hours and 6 hours. So they both have the same time. Okay, so then we say the distance of the brigantine plus 30, because he was already 30 miles out at sea, is equal to the distance of Lord Nelson. And we break that down. dB is equal to RB/TB. DLN is equal to RLN/TLN. Then we substitute in the time, which is 6 and 6. And then we substitute in the value for RLN. The rate of Lord Nelson is 2 times RB. So 6RB plus 30 equals 2RB times 6. 2 times 6 is 12. Then we subtract 6RB from both sides. That gives us 30 is equal to 6RB. Divide both sides by 6, and 5 is the rate of the brigantine. So 5 is the rate of the brigantine, and then we drop that in here, and we say 2 times 5 is equal to 10, which is Lord Nelson's rate. So, and he was going twice the speed here, and twice the distance, apparently. 5 times 6 is 30. 10 times 6 is 60. All right, let's do the next one. All right, in this problem, it says to find the lateral surface area, find the surface area of a right circular cone that has a base radius of 7 feet and a slant height of 19 feet. So first we find the area of the base because it wants a total surface area. That's pi r squared. So pi times 7 foot times 7 foot is 49 pi foot squared. And then lateral surface area, that's going to be the top of the cone here, that upper part, is pi RL. L is slant height. So pi times 7 feet times 19 feet is equal to 133 pi feet square. We add the two together. 9 and 3 is 12, carry 1. That's 8. Bring down the 1. 182 pi feet square. And that's the answer to that one. All right, in this problem, the key is that the x is not under the square root sign and the y is not under the square root sign. So we have square root of 2 times x plus square root of 7 times y. Okay, so it's not the square root of 7y, square root of 2x. X and y are outside of the radical, and that's what's tripping up most people. So when you're multiplying, you've got square root of 2 times x times square root of 2 times x, which is what we have here, which gives us 2x squared. And then here we've got square root of 2 times x times square root of 7 times y, which will give us 14xy, square root of 14xy. Same thing in the second one. It's square root of 7 times y times square root of 2 times x, which would give us square root of 14 times x times y. When we add those together, there's 2 of them because we have that invisible number 1 right here. So 2 times square root of 14 times x times y. And then at the end, you just got square root of 7 times y times square root of 7 times y, which is 7y squared. You bring that down. So that would be the answer that you are looking for. So here we got to find the equation of the line that passes through 3, 1 and negative 2, 4. So I'm going to find slope first, 1 over 3 minus minus, and negative 4 over negative 2. That's going to be 5 over 5. So my slope is 1. So y is equal to 1x plus b. So now I'm going to sub in my points. I'm going to pick the positive just because it's easier. So 1 is equal to 1 times 3, which would be 3, plus b. Subtract 3 from both sides, negative 2 is equal to b. So I come back in here and sub it in. Y is equal to x, because we don't write the invisible 1, minus 2. That would be the equation of the line. All right, in this problem, we've got to find the total surface area of the right solid. And it gives us the base, and then it gives us an illustration of the height, which is 9 feet. So in this space, I'm going to break it up into 3 shapes that I can calculate. So I drew a little line here for the blue calculation. That's area 1. It's a triangle. And first of all, to get the dimensions of the triangle, I looked across and I saw that this is a radius of 2 feet here and 2 feet here. So 2 and 2 is 4. So this has to be 4 tall. And then if this is 7 all the way across and this is 4 feet, then this is 4 feet and this is 3 feet right here. So 3 foot by 4 foot, because it's a triangle, we divide by 2. 12 divided by 2 is 6 foot square for area 1. Area 2 is 4 by 4. 4 feet times 4 feet is 16 feet square. So then I have this half circle, which we know is pi r squared. 2 times 2 is 4, divided by 2 is 2. So I didn't do that right. Hang on. So that would be 2 foot square. So let me redo my calculations. I did that all wrong. So that should be 2. Okay. So now I need to put that in here. Change this. So that would be 2. So then this would be 4. So then this would be 22. All right, so there's where I made a mistake right there. So 2 times 2 is 4, divided by 2 is 2, 2 pi feet squared. So when we write all of these together and add them up, we can add our like terms to get 22 feet square, and then we have 2 pi feet. So 22 plus 2 pi feet square. That's the area of the base, so we put it in for the area of the base. And we're going to say 2 because we get the top and the bottom. So there's the top and the bottom here. 2 times that is 44 plus 4 pi feet square. All right, now to get the lateral surface area, we need the perimeter of this shape times the height. So we have 7 foot, 5 foot, 4 foot, 7, 5, 4. And then we have half of a circle with a radius of 2 foot, which we know circumference is equal to 2 pi r. Because it's a half circle, we divide it by 2. That cancels. So that equals radius pi. So that's 2 pi foot. So we put that together and we have 16 plus 2 pi foot. And that's our perimeter. So we put that in there. We multiply that times the height. So when we do that, we get 144 plus 18 pi, and that's all feet square. So I add the like terms together. I get 44, and 144 is 188. And then I get 4 foot plus 18, and that's 22. So I have 18 plus 22 pi, all feet square. And that's your total surface area for that problem. All right, in this next, we're supposed to find the equation of the line between these 2 points, 4, -1, and 1, -4. Not super hard. Do it the same way we did the other one. And we just take this point, -1/4, and then we have minus 4 over -1. So we get -5 and +5, which gives us a -1 as our slope. So we put that into our formula. Y is equal to -1x plus b. Now I'm taking this point right here, putting it in, so it's -1 for y, and a +4 for x, times that -1 slope gives us a -4. So when I add 4 to both sides, I get 3 is equal to b. So I take that 3 and I put it in for the b in our original, where we put the slope in. Now we put the b in, and that's y is equal to -x plus 3. And that is the answer you're looking for. All right, now this problem is one of your rate problems. It has to do with exponential growth. Let me get this calculator here. So we have the original amount. It says the number of bacteria in the Petri. I don't know why it says Patron. It must be a typo. It should be Petri. Quadrupled every hour. So we have a rate of 4 times every hour. So the time is 24 hours. It says if there were 1,000 at the very beginning at t is equal to 0, how many bacteria were there in 24 hours? So the amount in 24 hours is 1,000 times 4 to the 24th power. So the first thing we're going to do is we're going to do the exponent. Because of PEMDAS, it tells us to do the exponent first. So we do 4 with an exponent of 24 equals this, times 1,000, and it tells us 2.81 with an exponent of 17. This is already in scientific notation for you. You just have to write 2.81 times 10, and it gives you the exponent is 17. That's all you have to do for that problem. All right. For this problem, we've got a binomial set here. So we are going to multiply each one in the first times each one in the second. So 3 times 3 is 9. And 3 times -square root of 2 is -3 times the square root of 2. All right, 2 times square root of 2 times 3 is 6 times square root of 2. And 2 times square root of 2 times -square root of 2, these two make -2. So 2 times -2 is -4. So I combine 9 and a -4 to get a +5, and a -3 times square root of 2 plus 6 times square root of 2 to get a +3 times square root of 2. And that would be my answer. All right, here is the purple octagon prism. So the formula for area of an octagon is 4.8284 times a squared, where a is the length of a side. So the length of the side here is 5 foot. So we say 4.8284 times 5 foot times 5 foot gives us 120.71 feet squared. This is the area of the base. That is what this top is. So we multiply that by 2 to get the top and the bottom. and that's 241.42 feet squared. Now we need to get the lateral surface area, the sides. This is an octagon, so there's 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. And they are 5 foot wide by 5 foot tall. So they're 5 by 5. So we have 8, 5 by 5. So that's 25. 8 times 25 is 200. So we add the area of the bases, 241.42 feet squared, and the area of the sides, the LSA, 200 feet squared. We get 441.42 feet squared is the total surface area. Now again, the area of the base is this, 120.71 feet squared. And to get the volume, we take the area of the base times the height, which is 5 feet. And we multiply that, we get 603.55 feet cubed. And that would be the other answer you are looking for. So here's one. I think this is total surface area. It's first, then the area of the base, and then volume is the third one you're looking for. Okay, in this problem, you've got 3 questions. You've got 2.5 cubed. Let's pull up my calculator. I'll show you. You just say 2.5 exponent 3. 15.625. All right, and then 0.5 xy, 0.5. And we just want 4 decimal places, so we stop here behind the 1. And then we know that when we have a fraction for an exponent, this is going to be the root or the index of the radical. So we put that here and we write 3.14 one time to the 1 power. So then all we have to do is put 3.14 to the 3rd power or to the 3rd root. And it's 1.4643. That's the 4th decimal place. And that's how we would find those. All right, in this problem, we're supposed to factor. And whenever you have something like this that you can't factor, it's got this lead coefficient. One of the things that you can do is divide everything by the lead coefficient to factor it. Or you can do the multiplication of the first term times the last term and find the 2 factors that give you that answer. So 4 times 1 is 4. The 2 factors that give me 4 are 2 times 2. That also equal 4 in the middle. The factors of 4 that give me the number in the middle are 2 times 2, right? 2x and 2x gives me 4x. So I'm able to factor this as I'm going to take the numbers or the values out of here and the values out of here that are in common. So I've got 2x squared or 4x squared plus 2x. I can take a 2x out of both of these. So 4x squared divided by 2x is 2x, and 2x divided by 2x is 1. So over here, I can't really factor anything out. So the only thing I can do is multiply that by 1. I can take a factor of 1 out because there's always a factor of 1. So plus 1. So 2x plus 1 times 2x plus 1. And if you're not sure if that's a little bit like, I don't know, that doesn't sound right, you just try it. 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. And 1 times 1 is 1. You add it together, 4x squared plus 4x plus 1. That's the same thing we started with. So we know we factored it right. So you need to have 2x plus 1 and 2x plus 1. And that should be what you get. All right. You could have also written that as 2x. I'm going to check that just to make sure. 2x plus 1. 2x plus 1. I just want to check it. Yeah, that's correct. All right, so let's look at the next one. All right, in this problem, we have got a fraction minus a fraction over a fraction minus a fraction. So we need to put these as one term. So we find a common denominator of x squared. So we multiply this fraction by x over x. And we get mp squared x minus z over x squared, because when we say x times x, we get a common denominator, right? Make that one fraction. Same thing for the bottom. Common denominators can be x squared. We have to multiply this one times x over x in order to get, so multiply by x over x, we get 5ax over x squared. So it means they have the same denominator. We can write them together. Y minus 5ax. So then we're going to do keep it, change it, flip it. And we do mp squared x minus z over x squared times, we flip this one, x squared over y minus 5ax. So the x squared cancels each other. And then we have mp squared x minus z over y minus 5ax. So this would be in your numerator blank, and this would be in the denominator blank. Okay. Let's look at another one. All right, I thought I would walk you through this one instead, because it's kind of complex. So the first thing I'm going to do is I'm going to get rid of x to the 0. It's gone. It doesn't mean anything. It just means a factor of 1. 2 times 1 is 2, still 2. So we have 2 squared, right? So then that would become 4. Let's do the numerator first. I'm sorry. I'm going to get rid of that, and then that becomes a 1. So this becomes 2 squared. So now let's do the numerator up here and get that resolved. So in order to get rid of these parentheses, I've got to apply just -2 to the positive 2. So it's going to be 4 x squared y negative 2 x to the negative 4 y squared x y, right? So this would be 2 squared. So that'd be 4 x squared y to the negative 2 x y, right? You follow me so far? Okay, so 4 divided by 4, those cancel. X squared, those cancel. Y negative 2, those cancel. X, that cancels. Y, that cancels. So the only thing I have left is x to the negative 4 y squared. And if I write this with no negatives, I have y squared over x to the 4th. Now I'm not sure which one Jupiter's going to take, so I'm going to try both of them. Let's try the first one. X to the negative 4 and y squared. I think that's what I have. Yeah. Let's see if it takes that. Nope, it's not that. So I'm going to try again. So I'm going to do fraction style. Y squared x to the 4th. And that's what it wants. So that's what when you have those negative exponents, it doesn't tell you exactly how it wants the answer. You try it one way, and then you try it the other way with all exponents positive, or all exponents negative, or everything in the numerator, or everything in the denominator. You just have to use what you know about moving those exponents from the numerator to the denominator around until you find the answer that it's looking for. Okay? So I did the first one, and I knew this was a quick option, an easy option, so I just shifted it to the bottom to get rid of the negative sign, and then this is the one that it wanted. All right, this is one of those weird factoring ones. So what you do is you say 9 times 1, so 9 times 1 is 9. And the middle term is 6. So we need factors that gives us 9 times 9 that also equals 6. And that'd be 3 times 3. because 3 plus 3 is 6. So this becomes 9x squared plus 3x plus 3x plus 1. The value remains the same because when we add 3x and 3x together, we get 6x. So the value of this expression has not changed. We just learned how to divide this so we can factor it. So I see here that I can pull 3x from these two. So I'm going to get 3x times 3x plus 1. And then this is already 3x plus 1. The only factor I can pull from here is 1. So it's going to be plus 1 times 3x plus 1. So what I have is 3x plus 1 times 3x plus 1. Let me check it. And I've got 3x plus 1. And then 3x plus 1. And if you're not putting your parentheses on there, you have to put the parentheses in there in order to get it to do right. So that would be your answer. Okay? Let's see, was there another one? (5z squared plus 2z minus 7). All right, so here is 5z squared plus 2z minus 7. I'm going to take the 5 and the negative 7. I multiply to get negative 35. And the factors that I can multiply to get negative 35 that will give me a positive 2 are 7 and negative 5. So I put those in here. The value hasn't changed. If I combine these terms, I still get a positive 2. But I am going to rearrange them so that the 5s are together and the 7s are together. So then I can factor out, and I can get 5z times z minus 1 plus 7 times z minus 1. These are the same, so I put them second. 5z plus 7 times z minus 1. When I multiply them out, I get back up to here. All right, so that's what I'm doing. All right, in this problem, I'm going to say 3 times 5 is 15. And 3 times negative 3 times square root of 2 is negative 9 times square root of 2. 2 times square root of 2 times 5 is a positive 10 times square root of 2. And 2 times square root of 2 times negative 3 times square root of 2 is a negative 6 times 2, which is a negative 12. All right, so 15 minus 12 is 3, and a negative 9 and a positive 10 is a 1. So the answer is 3 plus square root of 2, because we know we've got that invisible 1 right there. Okay? So whenever you're solving any of these equations that you're looking at, you've got to remember your operations and what you're actually doing. You want to remember and understand inverse operations and how to take things apart. This is mainly, it's not about knowing how to do the math. This is about how to logic out a solution. So I've got this term here plus this term. I want to get x by itself. That's the goal, to solve for x. So I'm going to undo putting this with this term by subtracting it. That would be my first step. Okay, now I know that this is negative 2 times square root of x. So I want to get rid of this factor here. So I'm going to divide both sides by negative 2. This would cancel, and this gets square root of x, and negative is a positive. So now I have square root of x is equal to 5 over 2. Now I know that if I square this, I can get rid of the radical sign because it would cancel. But whatever I do to this side, I have to do to this side, right? So squaring this, square root of x times square root of x equals x. And this would be 25 over 4, because 5 times 5, it would be like 5 over 2 times 5 over 2. 5 times 5 is 25, and 2 times 2 is 4. So x is equal to 25 over 4. Okay, now when you get here, you do want to check your work and make sure that that's the right answer. So we put it back in to the original problem. So negative 2 times the square root of 25 over 4 plus 4 is equal to negative 1. So we're going to check that. All right, so negative 2 times square root of 25 is 5, square root of 4 is 2, plus 4 is equal to negative 1. Negative 2 times 5 is a negative 10 divided by 2, plus 4 is equal to negative 1. Negative 10 divided by 2 is negative 5, plus 4 is negative 1. So this is the solution we're looking for. All right, so that's how you do these. Think about each step. How do I undo this situation that I find myself in? We want to get this by itself, so we eliminate the other term by subtracting it. Or if we have to, adding it back if we took it away. Then we have this multiplication going on, so we undo it. So then this becomes a positive because you have negative over negative. Then we squared both sides to get rid of the radical sign, which gave us x by itself and 25 over 4. So just take your time, okay? Breathe through it and just think, what is my next logical step? What can I undo next and apply it? All right, let me see if you have another. All right, in this problem, we need to solve for m, which is right here. So we first find the common denominator, which is MD, M and D here, and we multiply that by each term. I'm canceling out what we can so that we can eliminate the denominator. So here, m cancels itself out, so we have dx. D cancels it out, so we have mc. And then there's nothing to cancel out, so we have d squared m. I'm going to add mc to both sides to get all my m's on the same side, which gives me dx is equal to d squared m plus mc. I'm going to factor out my m's and get m times d squared plus c. And then I'm going to divide both sides by this factor, d squared plus c, which gives me dx over d squared plus c is the value of m. I'm going to type this in and see if this is the way it wants it. So dx over d squared plus c. And that's correct. All right, to do these problems, we want to get rid of this square root in the denominator. That's one of those things like a negative that we just can't have in a denominator. So to get rid of it, we multiply everything by this, by the denominator over the denominator. And if you look at this, it's actually just the value of 1 written in a different form, because this over this is equal to 1, right? But that allows us to have the right, because we're multiplying by the identity of 1, so we're just changing the format, not the value. So here's what we get. We get 2 times square root of 2, and then 3 times square root of 6 times square root of 2, which would be 3 times the square root of 12. And then this would be square root of 2 times square root of 2 would be 2, because then that would be square root of 4, which we know would resolve itself as 2. Now we can reduce this. This actually becomes 4 times 3. So if we look at it like that and say 4 times 3, we know we can pull the 2 out. So 3 times 2 becomes 6. The answer is 2 times the square root of 2 plus 6 times the square root of 3 all over 2. And we're still not done because these coefficients can be reduced. So 2 divided by 2 would be 1, which leaves the square root of 2. And then 6 can be divided by 2, which leaves 3 times the square root of 3. That would be your answer right there. All right, and let's see if there's another. All right, here is the next one. So first off, right away, let me get my pen out. This becomes a 1. So then this becomes an 8. This becomes a 4. And negative 2 squared becomes a 4. All right, so I've got negative 2, negative 1 minus 4, negative 8 minus 2, negative 3, so it's a positive 3 times 4. All right, so let's resolve this. Negative 2, I've got negative 5, negative 10. And then this is plus negative 2. And then I have 3 times 4, which is 12. All right, so negative 5 times negative 10, that's going to be 50 plus negative 2 and then 12. All right, so that's going to be 48. Negative 2 times 48 times 12. So we can just plug that into the calculator because that's an awfully big number. So 2 negative times 48 times 12. Negative 1,152. So let's make sure we're right. And that's correct. All right, let's see if you have any more. All right, that looks like the last one you sent me. Let me know if I missed any. If you have any more questions, please go ahead and message me those. Try to get them in before Wednesday. That way I can get them, all the old stuff out of the way so you're ready for class on Thursday. I don't want you to have all this backlog of stuff to have to deal with. So whenever you have the time, whenever you get on your math work, send them to me then. Just go ahead and message me then. And I may not get to them till that evening, or if you send them to me late in the evening, I might not get to them till the next morning. But because I'm old and I go to bed early. But just send them to me when you do them, and then I'll tackle them as soon as I can. Okay, sweetie? I hope this really helps. Like I said, I think I got them all. If I didn't, please let me know. And have a great week. And just know that Anna and Melanie and we are all here for you. Okay? And we love you. And you can talk to us about anything, and we will keep it private. And we will see you in class on Thursday.